Okay, girls, so I'm just going to go back over what a geometric sequence and bring it into geometric series then. So a geometric sequence, this is what I went through in class today. So a geometric sequence, also known as a geometric progression, is a set of numbers where each term after the first is found by multiplying the previous term by a fixed non-zero real number called the common ratio. For example, the sequence 2, 8, 32, 128 is a geometric sequence. And you can see, how do you get from 2? How do you get from 2 to 8? You multiply by 4. How do you get from 8 to 32? You're multiplying by 4. How do you get from 32 to 128? You're multiplying by 4. So it's a geometric as the first term is 2 and the common ratio is 4. Similarly, 10, 5, 2.5, 1.25. So how are you getting from 10 to 5? You're dividing by 2. How are you getting from 5 to 2.5? You're dividing by 2. How are you getting from 2.5 to 1.25? You're dividing by 2. So for this geometric sequence, you can see that the first term is 10 and the common ratio is a half. So the sum of the terms of a geometric sequence is also known then as a geometric series. So the sequence is obviously where you've just the terms in I suppose one after the other, right? Laid out one after the other, whereas a geometric series is where we're adding all of them together. Okay, sorry. So as I was discussing today, right, the general term of a geometric sequence. So let A be the first term. So A is always the first term, right? We always call that the first term of any sequence. And we're going to let R now be the common ratio. So it's not a common difference, it's a common ratio. So the table below shows the first 5 terms of a geometric sequence. So T1 is always A. But how are you getting from term 1, which is T1, to term 2? You're multiplying it by R. How are you getting from term 2 to term 3? You're multiplying it by R, being the common ratio, so that gives you AR squared. How are you getting from term 3 to term 4? You're multiplying this by R. This will give you AR cubed. How are you getting from term 4 to term 5? You're getting multiplying the previous term by R, which will give you AR to the power of 4. So therefore, what is the nth term, or Tn, of the sequence, which basically would mean we would be able to get any particular term in this sequence. So note how in Tn, excuse me, the power of R will be n minus 1. And it makes sense, right? Because if you look at it, see, the general term for a geometric sequence is Tn is equal to AR to the power of n minus 1. Because what's term 1? Term 1, you're putting in 1 for n here. So you'd have AR 1 minus 1, which is 0. R to the power of 0 is just 1. So therefore, this would be A. And so on. Term 2, so you're putting in 2 for n. So you'd have AR to the power of 2 minus 1, which is AR to the power of 1. That's what you have here, okay? Now, this is in your formula and tables book, but I would take it down as the general term. So we're saying where A is the first term and R is the common ratio. And remember, I went through just kind of how it's used in real life applications here, or real world applications. Okay, so this is the derivation for the formula for the sum of a geometric series, right? Now, you don't need to know this, but it's just kind of showing you how they come up with it. So write out the series. So the sum would be first term A plus AR squared plus AR cubed plus dot 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 all the way on to AR to the power of n minus 1. Now, say we're multiplying both sides then by the common ratio. So basically you're multiplying R by Sn, so everything gets multiplied by R. Okay, so that will give me this list of, or this geometric series then. AR plus AR squared plus AR cubed plus AR to the power of 4, all the way down to AR to the power of n. So therefore, we're going to be subtracting sequence 2 from sequence 1. So if we subtract one from the other, it comes out then to be, like if you think that's Sn minus R Sn, we get A minus AR to the power of n. So therefore, if you think about it here, right, Sn, right, say if we're taking out Sn to be our common ratio here, our highest common factor here, we get 1 minus R, which is equal to A times 1 minus R to the power of n. All they've done is put this together and taken out A as the common factor. So then that just simplifies by bringing, like you want to isolate and get Sn on its own. So Sn is equal to a bracket 1 minus r to the power of n, all divided by, and bring this over to the other side, 1 minus r. So that is the sum of the first n terms of a geometric series is given by this. So Sn is equal to that. Again, this is in your form and tables book. A is the first term again, and r is the common ratio. And also, if we multiply both the numerator and the denominator by minus 1, we can write Sn is equal to a bracket r to the power of n minus 1 divided by r minus 1. And this formula is useful if the common ratio is greater than 1. Okay, so if the common ratio is greater than 1, you can use this. But basically, it's just writing this in this order. Okay, so I take those two formulas down as well. But again, you don't need to know how to derive the formula for the sum of geometric series. It's just going through it there. Okay, so just these are the two, again, just reviewing what we've gone through. So the sum of the terms of a geometric sequence is known as a geometric series. And the formula for the general term now is Tn is equal to a r to the power of n minus 1. It's in your formula and tables book, as it says here. And where n is equal to the first term and r is the common ratio. Then the sum of n terms of a geometric series is Sn is equal to a bracket 1 minus r to the power of n, all divided by 1 minus r. Again, it's in your form and tables book, but just know when to use it. So let's look at this particular example here. So the first three terms of a geometric series are 5, 10, and 20. Find Tn and find Sn. Okay, so let's look at what we have. Right, we 5, 10, and 20. Okay, what's the first term? Right, think about what we need to fill in. We need to know the first term a, so the first term is 5. We need to know the common ratio. Remember, we're going to write in terms of Tn first of all, and then we're going to work out the first 5 terms. So how are you getting from 5 to 10? You're multiplying by 2. How are you getting from 10 to 20? You're multiplying by 2. So let's write down our general term formula first of all. And let's fill in what we have. Okay, so obviously how you can get the common ratio, is you can divide the second term by the first term, and that should equal to the third term divided by the second term, and it should. 20 divided by 10 will give you 2, 10 divided by 5 will give you 2. So now fill in what we can. So we've got 5 for a times 2 to the power of n minus 1. Then let's do Sn. Okay, so again, this first term is going to be a, the common ratio is going to be r. So fill in what you can, simplify it, and you get Sn is equal to 5 times 2n, 2 to the power of n minus 5. So all I've done here is just multiplied across by minus to get rid of the minus 1 underneath here. So if you multiply across by minus 1, that will get rid of that, and then simplify then to this. Now that's not completed the question, because now we need to work out the first 3 terms, okay? So, it simplifies this even further. So we have 5 bracket 2 to the power of n minus 1. So the first, I didn't actually do that answer, but you actually had to work out the first 3, I'm reading this wrong. The first 3 terms of a geometric series are given. I thought I went to find the first 3 terms. Apologies for that. So actually, yes, you've answered these 2 parts right. That's all you have to write is the 2 examples for Tn and Sn, and the two formulas in terms of n. So you're leaving them in terms of n. But as I was saying here, you have the first 3 terms. What am I saying? Why would you have to find the first 3 terms? But you can go and find T4 now, or you can go and find, which obviously you get T4 by multiplying 20 by 2. But say if you want to work out T50, so the 50th term, or if you wanted to work out the sum of the first 50 terms of this geometric series, we could just put in S50 into this one here, okay? Okay, another example then. Right, so this is where we're using real life applications then. So an initial population of 60 turtles triples in size each year for 5 years. So the initial population, so A is equal to 600, and it triples in size. Find the growth factor for the population, and then find the size of the population at the beginning of year 6. Okay, so let's think of what we have. So the sequence is geometric because it triples, right? And the growth factor, or the common ratio, is 3. Okay, so it's tripling, so it's going to be 3. So the next thing it says, the size of the population at the beginning of year 6. So isn't that really working out what T6 is equal to? Because year 1, is obviously the initial population, which is 600. Year 2, year 3, year 4 triples every time, okay? So what we're going to do is we're going to set up our formula for Tn. So Tn is equal to a r to the power of n minus 1. Now what is a? A is 600. What is r? The common ratio of 3. Fill in what you can into your Tn formula, and then remember you're finding T6. So wherever there's an n now, you're putting in 6. So the size of the population of the turtles at the beginning of year 6 is going to be 145,800. So that's a lot, isn't it? Okay, another example then. So these examples are taken, the ones that are in orange are taken from your textbook. So you can take them down as examples, or you can just look at them in your books. So show that the sequence Tn is equal to 1/4, all in brackets, the power of n is geometric. Okay, so the important thing to remember here is this, okay? So like where you want to show that an arithmetic sequence, to show that a sequence is arithmetic, we would be saying like T2 minus T1 is equal to T3 minus T2. Or, yeah, like that's basically, I suppose, for an arithmetic sequence, I'm thinking, right? That'd be just the example. But for a sequence that is geometric, how you show that it is geometric is you put Tn divided by Tn minus 1. So basically it'd be like term 2 all over term 2. Sorry, term 2 all over term 1, or term 3 all over term 2. And if it's constant, then it's correct. So let's look at what we have here, right? And we're dealing with just in terms of Tn. So we don't know what term 1, term 2. So Tn is equal to 1/4 to the power of n minus 1. Tn minus 1 then, so literally that's just changing the power of n to n minus 1. So now we're putting Tn over Tn minus 1, right? Now think of your laws of indices, okay? When you have a number to the power of something when the base is the same above and below, and you have the power of n here and the power of n minus 1, you just take one away from the other. Remember, you just subtract the powers. So this becomes n minus, all in brackets, n minus 1. So you're minusing everything inside the brackets, which becomes 1/4 to the power of n minus n plus 1. So that becomes 1/4. And because that's constant, that satisfies that the sequence is geometric. So we have 1/4 is the constant, so therefore we can state that our original question, is Tn equal to 1/4 all in brackets power of n geometric? Yes, it is. Okay, another example. So these ones are taken from the text and test book. So I would actually take these ones down as examples. They're very good. And again, just to clarify how some of the characteristics of a geometric sequence. T1, term 1 is equal to A. How you get the common ratio, you divide term 2 by term 1, or term 3 by term 2. The general term Tn is equal to A or to the power of n minus 1, and also Tn plus 1. So think of this as Tn, and Tn plus 1 would be 1 plus 2, divided by Tn is equal to R. Okay, so what's this question asking us? So it's saying find Tn and T10 of the geometric sequence. 1, 1/4, 1/16, 1/64. So Tn then, let's set up, right? So we have our formula for Tn. We need A being the first term, R being the common difference. Okay, so sometimes you'll be able to spot what are you multiplying each one of these by to get to the next term, or what do you multiply the previous term to get to the next term, or else you're putting T2 over T1. So in this case, I'm going to take term 2, which is 1/4, putting that over term 1. That gives me the common ratio to be 1/4. So fill it in. So you'd have 1 times 1/4, all in brackets, power of n minus 1. Now they just multiply that out. And basically, I suppose if you think about it, this is 1 times 1 all over to the power of n minus 1, which is obviously just going to be 1, and then all over 4 to the power of n minus 1. Okay, so you're multiplying in. Remember your laws of indices, right? When you've p all in brackets power of q, you're multiplying that in, okay? So then we have Tn is equal to, they brought that back up, so 4 to the power of minus n plus 1, which is the same as saying 4 to the power of 1 minus n. Now you can leave it like that, okay? There's absolutely no problem in not leaving it like that. And then we have to work out T10. So anyway, there's an n now in the general term of this geometric sequence. You're putting in 10 and we get 1 over 262,144. Now if you put that into calculator, press the SG button, it will give you as decimal. It doesn't say though, okay? And as it's put as a fraction, I would have left it in that format then. Okay? So yes, take that one down as an example. And also these key notes, I would take them down in your notes as well. Another example then. So in a geometric sequence, T3 is equal to 32 and T6 is equal to 4. Okay, so the first instruction is find A, the first term, find R, the common difference, and then hence write down the first 6 terms of the sequence, right? So let's write down in terms of n anyway what T3 is. Okay, so firstly, Tn is equal to the general term, which is AR to the power of n minus 1. T3 then is going to be AR to the power of 3 minus 1, which is going to be AR squared. Now what are we told that T3 is equal to? T3 is equal to 32. So we're going to let AR squared equal 32. Secondly, we're told that T6 is equal to 4. So T6 then is equal to AR to the power of 6 minus 1. So that's going to be AR to the power of 5. What is T6 equal to? 4. So AR to the power of 5. So now what we're going to be doing is we're working out the first term. We're working out the common difference. So couldn't we put T3, which is AR squared, over T6 or divide one by the other to show, and like that would give us, say, the common ratio then. And I know I said to you, like, it's usually the previous divided by the current one divided by the previous, but it still works for T3 and T6. Okay, so AR to the power of 5 divided by AR squared is equal to 4 over 32. So I'm literally putting the answers over each other. Crossing out the A's, we're getting R5 divided by R2, which will give you R cubed, which is equal to 1/8. And we get R then to be the cubed root of 1/8, which is a half. Okay, now so R is equal to half. So if R is equal to a half, A then substitute in, like it's like you're literally doing substitution in algebra, putting in a half for R. So we'll get A times a quarter, because a half squared gives you a quarter is equal to 32. And then just simplify by dividing in a quarter over the other side, and simplifying or isolating A, we'll get A is equal to 128. So therefore, we have A is equal to 128. We have the common ratio to be a half. So we could actually just work it out ourselves then without having to use the formula. So 128, get a half of that, get the next term. And we're looking for the first 6 terms. We're getting a half 64, we're getting a half of 32, we're getting a half of 16, a half of 8. And a half, that will stop then at the first 6 terms. So we could keep going, getting a half of 4, which will give me the 7th term, which will be 2, and so on. Okay, so another good example to take down. Okay, let's look at this one. We have algebra, right? So we have 3. X plus 6 are the first 3 terms of a geometric sequence of positive terms, right? So positive terms mean obviously you're not going to have a negative number as part of the sequence. Find the value of x. Okay, that's our first thing, right? So it's in terms of algebra. So what do we know from our geometric sequence? That term 2 divided by term 1 is the same as saying term 3 divided by term 2. So I'm going to use that fact. So I'll say x over 3 is the same as saying x plus 6 over x. Okay, and you could just cross multiply here, right? So if we cross multiply here, we'll have x squared is equal to 3x plus 18. We'll form a quadratic trinomial then. So bring over the 18 and bring over the 3x. You'll solve then to get your 2 factors. So you've got x equal to 6 or x is equal to minus 3. Now, we have to go with one of those answers. So which answer would we go with? 6, obviously, because it said that they're positive terms. So we can't go with the minus 3 because obviously the second term would be minus 3 and that doesn't satisfy what they said the characteristic of this particular sequence is. Then what does it ask us? Part 2. The 10th term. So find the 10th term of the sequence. So let's work out the general term. So we have Tn, put down a formula first of all, is equal to A R to the power of n minus 1. Now, A is equal to 3, have that. X is equal to 6. And then if you think the next one is going to be 9, isn't it? Okay, so we would have 3, it's going to be 12, what am I saying? X is equal to 6. So we have 3, 6, 12. So what is happening every time? we're multiplying by 2. So the common ratio here is 2. So fill that in. We'd have AR to the power of 10 minus 1 because we're looking for T10. Now remember, R is 2. So fill in your A, which is 3. Fill in your R, which is 2. And all to the power of 9. Put that into your calculator and you get 1,536. So that basically means if we were to list out all the terms of this particular geometric sequence, the 10th term would be 1,536 because we're multiplying by 2 every time. Okay, will I go through? Yeah, I'll go through these two, right? And it might even be spread out over the next lesson that I have with you, okay? Or will I wait? No, look, I'll go through this one, okay? So the product of the first 3 terms of a geometric sequence is 216 and their sum is 21. Okay, product, remember, is multiplication, sum then is addition. Given that the common ratio R is less than 1, find the first 3 terms of the sequence. Okay, so this again is another good example to take down. Right, so we're letting A over R, A and AR be the first 3 terms, right? And the reason being, 1 second now. Okay, so because it's A over R, you can also let the first term of a geometric sequence be A divided by the common ratio. And then obviously the next term can be A. Now, I don't want you to be put off by this because we all, up until now, we've said the first term of a geometric sequence is A, but just it's the same kind of procedure, like you're dividing it by just the ratio in this case, right? But if we let the first 3 terms be A over R, A and AR, whereas you're usually dealt with the first 3 terms be A, AR, AR squared. And that should still actually work out for you, right? It's just that you'd have AR squared that you'd be dealing with. So it said the product of the first 3 terms equal to 216. Okay, so we would have A over R multiplied by A multiplied by AR, right? Now, very simply then, the R's will just divide into each other and you'll be left with A times A times A, which is A cubed. So A then is equal to the cubed root of 216, which is equal to 6. Okay, so that gives me firstly my first term, which is 6. Okay, the next thing, we're also told that the sum of the 3 terms of a geometric sequence add to 21. So we'll add them up now. So remember now we can fill in what A is equal to. So 6 over R plus 6 times R is equal to 21. Just simplify, use your common factor, or you could do your common denominator, being R here, or you're multiplying across by R. So you'll form a lovely quadratic trinomial. You could use your minus B formula or your guided method here. Solve, get the 2 factors, solve, then and get your 2 roots. So R is equal to half or R is equal to 2. So does it tell us anything? It says that given that the common ratio R is less than 1, find the first 3 terms. So R is less than 1, so therefore R must be the half here. We ignore, or the R is equal to is not applicable. So therefore the first 3 terms are 6 over a half, 6 and 6 times a half. So that's going to be 12, 6 and 3. Okay, so yeah, for this one here, right, basically A over R can come as a term before A, right? But I'd actually like you to try even by AR squared, and it should still work out for you, right? It should still work out for you if you put in A times AR squared, and it'll simplify further, and you'll still get A is equal to 6 and you still get R is equal to half. Okay, so I'm going to leave you with those examples. I've kind of rambled on and just give you time to stop it. And even if you don't get a chance to take it all down this class, you could do it for the second class of the double. Okay.